Okay, to continue with this idea of demand-side solutions for climate mitigation, in other words, reducing impacts from demand-side solutions where consumers are contributing to mitigation by reducing emissions via their choices, which we talked about a little bit. This goes a little bit further and introduces a framework called Avoid, Shift and Improve, and starts with a very good way of depicting the potential contributions. So mitigation potentials in end-use sector classified in ASI options, Avoid, Shift and Improve options. They review a bunch of studies estimating demand-side mitigation potentials associated with the demand-side greenhouse gas ASI emissions reduction strategies, and summarized the results as central values and full ranges. Without going into the details, I will show a table which looks at specific aspects where these strategies in avoid, shift and improvement can be implemented in each sector. And the sectors are looked at here as human settlements, which include building, transports, including shipping and aviation. And there is the food sector and industry, and these are the estimated emissions, projected emissions by 2050. And as we have done before, we looked at how much of that can be potentially reduced by these demand side solutions in each. So these are the color codes: avoid, shift and improve. We'll see what they mean in a minute. So in the building sector, you can see that the estimated emissions are up here in gigaton CO2 equivalent of about 9 or so in 2050, and avoid takes out a chunk of it. Shift has a much larger chunk, and the improve part has a bit of contribution, and this is a total contribution of 78% or 6.8 gigaton CO2 equivalent in the building sector from the ASI approach. And similarly in land transport, shipping and aviation, there are 40%, 69% and 62% respectively. Whereas these numbers are larger, the total emission is smaller. So this contribution here is 5.8 gigaton CO2 equivalent in land transport, 1.3 gigaton CO2 equivalent here in shipping, and 0.7 gigaton CO2 equivalent in aviation. Similarly for food, there is a total there is not a small chunk called improve, but doesn't even show up properly, and the uncertainties in the shift are quite large, which has to be kept in mind. Dietary shifts, for example. So the total saving from demand side solutions is expected to be having a potential of 41% or 7.3 gigaton CO2 equivalent from the food emissions in 2050, which is quite significant at more than 15 gigaton CO2 equivalent. And finally, in the industry sector, you can accomplish again 41% or 6.5 gigaton CO2 equivalent of reduction in greenhouse gas emissions using this avoid, shift and improve strategy for demand side solutions. So what exactly are they? So here is the demand side mitigation strategy and mitigation potential table in the end use sectors. I won't go into all of these specific items, but we will go through one of them to get a sense. So here are the end-use sectors: housing, leisure and services, which include buildings, and mobility and accessibility, nutrition, which is food and products and materials. This is the demand side mitigation strategy continued here into mobility, and did I switch that around? Yes, I did. So let me stop that and restart. Okay, so mobility there. buildings, mobility, food, and industries, as we said before. So let's look at specific items here in terms of end-use sector, housing, leisure, and services, with a total mitigation potential of 78% or 6.8 gigaton CO2 equivalent, as we showed here. And that's the total emission by 2050 as projected. The mitigation strategies in avoid include sufficiency of energy and resources, include compact city and nature-based solutions from urban sector. We have discussed these elsewhere, but not in a particular context of demand-side solutions, but you can hopefully map them back. And of course, this includes building design, size, and use, which require behavioral and lifestyle changes. So they have the avoidance here has the potential for ASI, avoid, shift, and improvement of 10 to 40% with a central value of 25%. These are the references where this material is drawn from. In shift for housing buildings, we have improve access, switch to renewables, on-site renewables, microgrids, switch to lower carbon fuels, and electrification of space heating, cooling, cooking, hot water, and electrical uses. This has a potential of 30 to 70% with a central value of 50% in ASI reduction potential. Under improvement, it includes efficiency, improved building envelope, so loss of cold and heat, improved building technical systems for heating, ventilation, air conditioning, cooking, and electrical uses, smart home and digitalization, so Internet of Things and Internet of Everything and so on, which is already happening. We have looked at these elsewhere. Efficient appliances, control systems, and clean cooking with the potential of 30 to 65% range of CO2 equivalent emission reduction, the central value of 40%. Similarly, under mobility, accessibility, there are this is the total emission. There are various ways of avoiding, shifting, and improving, which include battery operated electric vehicles, shared mobility, active travel in highly accessible cities, teleworking, and so on and so forth. Further, the mobility accessibility also has for flights and shipping, you have aviation is of low economic value and demand is highly sensitive to prices. A carbon price of aviation fuel of US $400 per ton of CO2 would have the demand for aviation in 2050. So you have to look at the pros and cons of simply imposing heavy carbon tax on people who want to fly, and what unintended consequences that may have, including things like how important aviation is for cultural exchanges, for people who want to see the world, people who travel for business, and so on. Because if heavy tax is then transferred to consumers, because business travel is passing that carbon tax to consumers, then you're not accomplishing much either. And there are newer ideas in improving fuel efficiency of flights plus alternative fuels, which hopefully will come along with some sort of a game changer. Okay, so for shipping, there are ideas for reducing demand and slowing steaming, modal shift to train, and design and power system improvements are foreseen with various ranges of potentials here. For aviation, it's 0 to 40%, 47%, a large range with central value of 40%. For shipping, it has 40 to, remember here we only have avoid, no shift and improvement as such. 40 to 60% under avoid, 0 to 1% under shift, small percentage, and under improvement you have 30 to 50%. Okay, for nutrition, again, emission of 16 to 20 gigaton CO2 equivalent, but the ASI framework offers 41% reduction. Products and materials under industry offers with a 15.8 gigaton CO2 equivalent emission in 2050 offers 41% reduction at 6.5 gigaton CO2 equivalent. Okay, so you can read the details of these in avoid shift. Again, under nutrition we don't have improvement as such, and under products we have avoid in terms of material efficient services and lifespan expansion. So right now, since the 1950s, the economy took on the idea of building things that do not last very long, so that people keep buying new versions or new operating systems and so on again and again, whereas extending lifespan is another way of avoiding emissions. Shifting again, reuse, recycle, improving again things like energy efficiency. So if we look at the ratio of weighted sum of synergies between sustainable development goals and energy demand versus energy supply solutions, energy demand and energy supply solutions, and weighted sum of trade-offs between SDGs and demand supply solutions. There are some details in which it is these calculations are done. So on the demand side, you have things like building, industry, mobility, food, and demand overall. So obviously, larger the ratio, larger the positives for SDGs. Remember, we looked also at other things and how they affect sustainable development goals, and said some adaptation mitigation strategies are synergistic, some are trade-offs, and so on. So this is similar. High ratio of positive is good. So buildings and industry offer high ratios of almost 10 in terms of positive and negative effects on SDGs. Mobility and food are all smaller but still useful. Demand overall in terms of solution for mitigation would be around 6 here, whereas on the supply side the ratios of positive to negative are typically much smaller, and carbon capture and storage is right here. Depends on the various details involved in how these are calculated. So overall supply impact on SDGs is not that high in terms of positive versus negative, whereas demand side solutions can offer a much bigger range. So in terms of well-being, effects of demand side options on well-being in 19 different categories, magnitude and direction of the well-being effect. So I won't, obviously you can see the table here, it's quite complicated with lots of stars, footnotes, and so on, but just to look at the mapping, here are the SDGs, and here are the sectors ranging from food, water, air, health, sanitation, energy, shelter, mobility, education, communication, social protection, participation, personal security, social cohesion, political stability, economic stability, and material provision. And finally here you have supply side encumbrances, and this is the scale here going from high positive on SDGs, so the bluish colors are all on the positive side, high, medium, and low, and the yellowish colors are overall neutral, as we had seen before. White ones have no impacts, and the orange, dark orange colors are low negative and medium negative impacts, and the confidence levels are indicated in stars. So 3 stars, 4 stars, 5 stars indicate higher efficiencies. So we are looking at various metrics: building sufficiency, efficiency, lower carbon and renewable energy, food waste, overconsumption, animal-free protein. Under transportation we have teleworking and online education system, non-motorized transport, shared mobility, battery-operated electrical vehicles. Under the urban sector we have compact cities, circular and shared economy, systems approach in urban policy and practice, nature-based solutions, and in the industry we have using less material by design, product life extension, energy efficiency, and circular economy, where it's kind of an end-to-end use. of materials, recycling, reuse, etc. Right? So finally, gives you a sense that there is a very detailed mapping of demand-side solutions onto well-being to argue that there's plenty of room to have demand-side solutions accomplish their potential for mitigating climate change and reducing emissions and well-being, so they can be very synergistic. They don't have to be opposing each other, so that's a good thing. The assumption that preferences are exogenous or endogenous has an impact on the evaluation of solutions. So you have supply-side solutions and demand-side solutions, exogenous and endogenous preferences. So supply-side solutions worry about exogenous preferences based on current patterns of service. Provisions are appropriate and new technologies must substitute current supply side technologies closely. Whereas on the demand side, making existing technologies more efficient, which falls under improve, is appropriate, but shifting or reducing consumption patterns are insufficiently considered when exogenous preferences are modeled. Social dynamic, or how they are evaluated in terms of impacts of the solutions proposed. Social dynamics are often directed to enable consumption. So there are these external factors which tend to implicitly and explicitly play on people's consumption patterns. Under endogenous preferences, supply-side solutions, lack of orientation on what should be produced, alternative or partially objective metrics are required here for evaluation of solutions. On the demand side solutions, societies can choose to modify service provisioning systems and lifestyles, so alternative metrics and institutions are required. In other words, well-being needs to be properly defined and considered for synergy with demand-side solutions. We cannot just assume that people are buying things because they think it's good for their well-being. So you have to find the details of what the demand where the demand is coming from. Is it endogenous? Is it exogenous? And how the solutions can benefit well-being by playing on the supply side solutions and demand side solutions, and the metrics that are used to evaluate the solutions in terms of their potential for mitigation and reducing emissions. Okay.